welcome. In this video, I want to present to you how you can get 100% valid JSON outputs when working with LLMs and use it for different use cases like classification, where you want to be sure that the LLM is not hallucinating any class. You can use it to extract values from invoices, and generally every time you need some kind of structured JSON output. With this method, you get 100% guaranteed JSON. You will see here first the simple way people are usually trying to get JSON outputs. Maybe you're doing the same. You will see how it's done 100% reliably, and in the end I will also explain why exactly this is working. I am Leon, I am an AI engineer. I have right now running enterprise solutions in production which work with 10,000 inputs per day, and I've used exactly this method which I will show you here today to create reliable structured outputs. If you're interested in working with me, you can find my contact information in the description, in the comments. So let's jump right into it. Okay, let's quickly start by creating our virtual environment with UV. Install requirements. We also want to run Docker Compose up. Now let's look into the Docker Compose file. You can see we're working with vLLM here. vLLM is basically the industry standard. I use it in a production for industry applications all the time. We are using the Qwen3 1.7b, a small model, but it fits on my small GPU. I'm disabling the thinking. I don't want thinking, I want straight outputs here. Okay, what do we also have? You have here in the data folder synthetic support ticket data, 10 examples, and you can see we have order ID in some of them, but in others we don't have it. So here we import the OpenAI module, we connect to our vLLM instance, no API key needed, we get the model name here, and we also load our tickets. Here we can see an example ticket. Now this is the schema, the JSON output we want to have in the end. This is the Pydantic model here. Pydantic, basically you can load JSON into the Pydantic model or Python dictionaries, and it will automatically validate it and throw an error if it's not the correct schema which we have defined here. We want the customer name as a string, we want the correct category. We know category can only be one of four: billing, technical, account, or other. We have only these three priorities: low, medium, high. And the order ID, we know in our company the orders, they're always only integers, so anything else would be wrong here. It can also be none if the customer forgot it, and we want to have a summary as well. Now, simple approach, simple prompt where we ask for it. Please extract the customer name, these categories, priorities, order ID, 110 sentence summary, and it should be a JSON. We need to first also run the cells, and we have some functions here. The extract raw, this is with the simple raw prompt where we call the OpenAI completions endpoint, and we send our prompt inlet with the respective text from the ticket. We also have the validate function. There we will input the response we get from here, and first we try to load it directly with JSON. This might already return an error if the output is not correct, but if that is correct, then we also validate it through our Pydantic model, which I showed you earlier. If one of these fields is wrong, then we will receive an error here. So then the score function, which basically for every ticket runs our extraction function and then validates it. Now let's do it, and there we have it. You can see per ticket, we can see the output printed. Every ticket here is failing, and I can tell you already why it's failing. You can see this JSON markdown fence. LLMs are doing it all the time. So now we need to write a parser on top of that, which is removing the JSON fence, and then we can actually validate the actual content. So this is the first inconvenience we're encountering here. With this simple method, you would need to write a custom parser. You need to think about all the possible edge cases. You can see here another edge case. It created not available, but we defined the schema. It should only be none or an integer. Not available is incorrect here. Here it's actual string nimbus 1, 2, 3, 4, 5. We know it can only be numbers, so this will also return an error. One correct JSON, no markdown fence, and also the outputs here are correct. Now you can see with this simple approach, 90% failure rate, recurring errors. Now what can we try to improve it? You can just prompt it a little harder, make a better structure in the prompt, make it stricter. Maybe then we can get better outputs. Let's see how this works. Okay, there we can see we have actually 9 correct outputs, 1 failed. It validated the schema here because it outputted in category accounting, but we defined can only be count. But you can see we have some improvements. The order IDs, they're only null, they're only numbers, but still this is a 10% failure rate. If you would have now 100 tickets, 1,000, 10,000, maybe it's only 1%, but still 1% equals to 100 when you have 10,000 tickets per day, which might easily be the case for enterprise solutions. So the next problem is this is still a very simple schema. We have no nested structures. We could have some structures where the field here would be another JSON. So these simple prompt variations do not survive that. Okay, so what's the solution? Constraint decoding. Constraint decoding is simply implemented in the OpenAI endpoint by calling the parse endpoint. We send with our message also our Pydantic schema, and it automatically validates the output right away. And you can see here everything will be created correctly. 10 of 10 are correct, everything is alright. No. And if you look at one example here, perfect. Okay, now the explanation. Why is it working? So how does constraint decoding work? I will jump right to the picture here. So basically you need to think again, how does the transformer model work? It outputs tokens one by one. So each token just gets generated, and it's not that it generates one token, it generates a probability distribution over all possible tokens in the vocabulary of the LLM. So in this case, just for the example, we have only 5 here, but in reality you have hundreds of thousands, really big vocabularies. So in this example, we have generated the word, the JSON up to the priority already. And now in our schema, we would only allow low, medium and high, but the LLM would, without the constraint decoding, give the word urgent the highest probability. So without the constraint decoding, we would have the wrong word here sampled. But with our constraint decoding, a mask is created, and the mask is setting the probability of every token which is not in our schema to 0. So only the tokens are allowed which are correct based on our schema. And this again is only a simple example, but you can have nested schema, really complex extractions, and it would generate it perfectly. Of course, one thing you have to keep in mind: hallucination. This literal definition where it can only pick between these 4 words, this works also against hallucination, but the customer name, the summary field, which are custom strings, and also the order ID, which can be a custom integer. So yeah, we're validating only here if it's an integer, but the actual value can still be incorrect. So you still want to check against hallucinations, but the structure here with the parsed endpoint, with the constraint decoding, will be 100% correct. If you encounter any failure, you build a retry mechanism, and basically I have these constraint decoding methods running in production applications right now. I use it all the time. Don't rely on some naive prompts anymore. You can get a 100% correct schema simply like that. I hope this video did help you. As always, I will put the code on GitHub. Also let me know down in the comments if you're using JSON outputs in your projects and if this could help you. Thank you for watching. See you in the next video.